Hello folks, my name is Johannes and the company is Gringo Gadgets. I am showing you today one of our new products. It is a 32 digital input and 32 digital output board for the TRS-80 Model I. This hooks up to the expansion bus of your TRS-80. Cable is included, and you have 4 input ports and 4 output ports. Output ports here. Each port has 8 individual pins for the each output connector has 8 outputs, and each input connector has 8 inputs. Each connector also features 5 volt DC and ground, and also has some strobe signals that I'll get into later. There's a 5 volt DC supply, and that you provide either through this connector or you can provide it through any of the input or output connectors. And finally, your interface to the Model I expansion bus. Very simple. Plug the cable in and then plug this into your either the TRS-80 Model I directly or through the expansion interface if you have one. The only other thing you have to do is set a base address. The I/O board takes 4 addresses, so you just set the first address and then it'll use that address plus the next 3. So right now you can maybe make this out. It says here A7. That bit is on, which means the base address of this board right now is 128. If you use the basic instruction out and output something to 128, the signals will appear on output port 0. If you send it to address 129, it'll be output port 1, 130 output port 2, and so on. 131 would be the last address, which would be output port 3. If you use the INP or the input instruction, then you would be reading from the input ports. So if you do an INP on 128, you will read the state of these 8 pins. If you do an INP on 129, you'll read these 8 pins, and so on. When you do an input or output instruction, the result will be immediate. So if you do an out instruction, by the time the out instruction returns, the pins will be set, and they will stay set until you set them to something else.
Few moments later.
Alright folks, here we are all hooked up. Power is connected and the ribbon cable is connected to the expansion bus of my TRS-80. I have a little board that shows me the status of 8 output pins. It just plugs straight onto a port. Let me put this at an angle so you can see it. And here you see the 8 LEDs. If an LED is on, that particular pin is high. If the LED is off, the particular pin is low. So as you can maybe see, I have connected this to the second output port, OP1. So that means it's base address plus 1. Base address was set to 128. Plus 1 is 129. I am now going to issue the command, the basic command, out 129, 0, and when I hit enter, the LED should turn off. Bingo. Let's do out 129, 2. The second LED should turn on, which would be the one labeled 1. Out 129, 255. That's all bits set. Light show. So you also have 32 inputs, 8 on each port. If you read the base address, which is 128, you'll be reading the state of the inputs on IP0. 129 would read IP1, and so on. The center 8 pins are the actual input pins, and they are pulled high. So if you have nothing connected and you read IP0, then the value that you see is going to be 255. If you pull the second pin low, that one has a bit value of 2, then you're going to see 253. Okay, so let's do a read of IP0. The basic command is print INP 128, because 128 is the base address. and the result is 255. Now I'm going to ground one of the inputs, which is means pull it low. This is the ground pin, and we're going to pull low input 0.5, which is bit number 5, and that has a value of 32. So we should see 255 less 32 of 223. So print INP 128 and 223. The value that the TRS-80 will read is the value on the input pin at the time that the instruction is issued. Now here's a page from the manual that shows the pinout, and what you see is that each port, whether it's an output or an input port, has a ground and a 5-volt pin. You can again use that to draw power from the board, or you can supply power to the board. Here you see the 8 output pins for OP3, 8 output pins for OP2, OP1, OP0, and then here you see the 2 strobe signals. You have the active high strobe signal and the active low strobe signal. So this would basically always be inverted from this. And what the strobe signal does is you don't have to connect anything to it. In fact, in a lot of cases, you probably wouldn't. If you're driving relays or lamps or other regular loads through a transistor, please, if you're driving those kind of loads from the outputs, then you don't need the strobe signal. However, if you're using it as an interface to another computer, you probably need the strobe signal because it tells you when a new output instruction was issued by the TRS-80. When you issue an INP instruction, this pin will briefly go high, this one will briefly go low. When you issue an out instruction, this pin will briefly go high, this one will briefly go low. And again, you have individual strobe signals for each 8-bit wide port. All right, let's do practical applications. I have a paper tape punch machine that punches little holes in paper tape, ticker tape if you want to call it that. Was used in the old days for teletypes, later for CNC machines, program storage, you name it. This tape, as you can see, it has 8 data holes and a row of tractor holes that are used to feed the tape. The interface to the tape punch is not a serial interface. Instead, it is a somewhat proprietary parallel interface. What you have in that interface is 8 data lines. You have a punch command, which is basically a strobe. You have a motor on and a feed signal. So these are inputs, and they're marked as inputs. These are inputs to the punch machine. If I set the feed signal, then the machine will just simply spit out tape, waste tape. If I set the motor on signal, the motor will turn on and just run, waste electricity. And if you issue the punch command, it will punch the 8 data holes that are represented by the 8 data bits. So those 8 data inputs, the punch command, the motor on and feed, are inputs to the punch machine, which means they're outputs from the TRS-80. The punch also has outputs, and those would then of course be inputs to the TRS-80. The outputs are a tape low signal, a tape error signal, a remote control signal, system ready, punch ready. Again, most of those can be ignored. Tape low and tape error, you may certainly want to interrogate those signals if you want to, depending on your application. Remote control, it's a switch on the punch and it tells you the status of the switch. Not important. The system ready is pretty much always asserted. It just means that the paper tape punch has turned on. And the punch ready signal means that you can send a punch command. So the sequence is this. The machine will signal punch ready, which is an output of the machine and input to the TRS-80. At that point, when the punch is ready, you set the signal on the 8 data lines and you issue the punch command. You issue the punch command until the machine says it's no longer ready. At that point, you deassert the punch command. It will punch the hole, and the punch ready will be reasserted by the machine. So it's a very simple one-wire handshake. And I'm going to show you that machine in action here in just a second. But just to summarize, an input to the punch machine is an output from the TRS-80, and an output from the punch machine is an input to the TRS-80. And here is the cable that connects to the punch.
What follows is a brief construction montage.
Okay folks, switching camera. Let's have a look at this interface in action. It's connected to the tape punch. Here is the beast. Alright. And I have written a little basic application that punches holes into the tape so it looks like text. And I am going to print hello world because that's what we do. It is done. Let's feed it out. Tear it off. Hello world. Oops, upside down. Well, hello world. Alright guys, that's it. Again, I apologize for the lack in production value. This is my first YouTube video. So if you're looking to get your hands on one of these interfaces, go to gringogadgets.com. You can also have a look at the instruction manual and leave comments, likes, subscribe, the usual stuff. Thank you.